Okay, so let's take a look. Some people did this. Some people did this. They did inverse norm. Okay, let me show what you did. They did inverse norm of 0.10. That means this. Left area of 10%. And they got negative 1.28. That's this number over here on this side. Do you guys see what I'm saying? Yeah. Inverse norm of 0.10. The beauty of this is it's a normal distribution, which means it's symmetric. So 10% over here, 10% over here means negative 1.28 here and positive 1.28 there. So you could do it that way, but you darn well better keep your negative straight and realize that if you're doing it over there, it really is on the other side. You're doing the opposite side, so you better make it positive.
Me and Joey did
1.28.
0.9.
Or, if you have 10% on the right, what percent is on the left? 90%. So then you do inverse norm of 0.90 and you'd get 1.28. Making sense? 15 seconds with your neighbors? Okay, take 15 seconds with your neighbors.
Yeah? This one's negative. So you were taking
Okay, now we have this weird, annoying one, right? That gets a little confusing. If I do inverse norm of 0.4175, then that means the area here is 0.4175, which means it's going to be like from here to maybe right there. And it's going to give me this z-score. If I did, do you guys see what I'm saying? If I do inverse norm of 0.4175, this area here, it'll give me that z-score. So I don't want to do that. But what I do want is I want this little tiny area here. If I can find this area, then I can do inverse norm of that and I'd be in good shape. So I don't know this one, but I do know this one. Do I know this area here?
Yeah.
What's this area here, guys? 1/2, right? It's half the data. So if this is 1/2, then I know that this, the blue area plus the orange area, has to equal 1/2.
Like that.
So if this plus this equals 0.5, then 0.5 minus this gives me that. So then you guys can go ahead and find that. So why don't you guys take a second and find that. Inverse norm in the left area. Alicia, what'd you get? Or what'd you do? Alicia? You still working on it?
No, I'm literally just look down and start moving on it.
No, so don't distract her. Go. This is going to be one of the harder problems on your homework, which is why we're doing it in class, because I want you guys to spend a ton of time on it. You know, when you get it in your homework, you'll have seen it before. All right, Gabe, what'd you get? What'd you do?
Still currently audit.
Okay. Guys, I want to go all the way to 9:45, but it looks like we are.
No.
Well, people are not doing their stuff. I don't know what to do. What was that? you're like, the heck with them. I don't care if they fail. Let's just do it. All right, that's fine.
So with these ones, do you want us rounding up to the second decimal, or?
Okay, so yes. So areas, you guys, areas, 4 decimal places. Z-scores, 2 decimal places.
Okay. So for 2 decimal.
Yeah. All right. So this area has to be the rest of it, 0.0825. So Carl, you did what?
I did the inverse norm of the 0.0825, and I got negative 1.3884, and then I just rounded it to negative 1.39.
1.39. So this is negative 1.39. Good. Okay, great. Like I said, that's one of the harder problems on your homework, so that's why I wanted to go over in class so you guys didn't spend 10 minutes kind of trying to figure it out. We can just kind of do it in class. Okay. So that's the basic inverse norm stuff. But now, in reality, what happens is you find the z-score and you say, and someone says, I need to score in the top 10% to get into this police academy or to get into Berkeley. And you're going to say, well, you need a z-score of, you know, whatever, 1.28. That's not going to help them a whole lot. You need to say, well, you need a GPA of blank. Do you know what I mean? You need to convert that z-score to a GPA or whatever it is you're talking about. So, how do we do that? How do we convert the z-score back to an x value? What is a z-score? What's a z-score again? How many standard deviations you are above or below the mean. How many standard deviations you are away from the mean. So it means that if I start the mean, if my z-score is 1.2, then I'm going to go for the mean and I'm going to add 1.2 standard deviations. If my z-score is negative 0.7, I'm going to start at the mean and I'm going to subtract 0.7 standard deviations. Does that make sense? So I'm going to have the mean, start the mean, I'm going to add whatever my z-score, that many standard deviations. So this is the formula. You guys should be writing in your sheets there. And this is where it comes from. It comes from that idea. And also, think about it, a z-score is equal to your x value minus the mean divided by the standard deviation. If I want to solve for x, I'd multiply both sides by standard deviation. So this side I get z times sigma. This side I'd get, these guys would cancel out. So then I'd end up getting x minus mu. And then I'm going to add mu to both sides. So then I'd end up getting mu plus z sigma equals x. Done. Because these two would cancel out. So that's where it comes from. Actually, it comes from common sense, right? How many standard deviations you are above or below the mean. You start the mean, you add that many or subtract that many standard deviations. All right. So that's just one last step at the end to tell your friend what score that needs to be. Because they're going to be like, be more helpful. Just don't say I need to score in the 1.28 z-score or higher. Tell me you need to have a GPA of 3.6 or higher, or 3.8 or higher, whatever it is, right? Okay, so here are your steps. I will circle the things that are actually important to you, which are draw a picture and find the area, draw a picture and find the area to the left of the value you want. So this is the part you should be writing into that first one. Then you're going to use inverse norm of the area left to find the z-score that goes with that area. And last thing you're going to do is you're going to convert your z-score to an x value. So that's the part that goes right in your handout, right the next thing. In fact, I might have been smart and, or not. I might have been really dumb and deleted that. Oh, that's terrible. Okay, no worries. So here's an example. Oh, did you guys see this other part here, the one below that? About this part here. You need this also. Do you have a z value and what the x that goes with it? In words, your data value, your x, equals the mean plus your z times the standard deviation. Write it, think it, understand it, hopefully. Okay. Okay. So let's go ahead and go through the example below that. So here's our Police Academy example. Who hasn't read yet? Rosa, you have read.
Police Academy candidates must score in the top 10% on a general abilities test. The test has a mean of 200 and a standard deviation of 20. Find the new lowest possible score to qualify. Assume the test scores are normally distributed. 1. Find the area to the left of the score you want. Then find the z-score we are looking for using
Inverse norm.
invert norm.
Great.
2. Then find the x value that goes with that z-score.
So we're going to do those first two steps. So first, 1, find the area to the left of the score you want. My score is 10% at the top 10%, which means that this is 90%. So I'm going to do inverse norm of inverse norm of 0.9, 0.90, 0.9. I'm going to get 1.28. That is my z-score I want right here. Now, so this is the first step, actually was the picture. Second step was the inverse norm. And the third part is the converting this to an x value. So my x value is equal to my mean, 200. You know what, maybe I better give you guys the whole thing. It's equal to my mean plus my z-score times the standard deviation. So my mean is 200. My z-score is 1.28. And my standard deviation is, what's the standard deviation? Standard deviation of 20. Right, my mean was in purple. My mean is 200. So if I do all those things and I get 200 plus 25.6, so you need to score 225.6 or higher to get into the Police Academy. Do you guys want 30 seconds of your neighbors on this one? Okay. So want you guys go ahead and do lab problem number 5. Or you know what? I'm going to wait. we'll do that one next class to give ourselves another chance to look at it. And you guys are done.